Okay, guys, we're starting the notes over chapter 3. This is 3.1. Just talking about the history of the atom. Now, we start with Democritus, and he was the person who coined the phrase atom, which means indivisible. He named that's the most basic particle. Now, Aristotle didn't believe in atoms, thought that matter was continuous. But what we see is the Greeks, they used reason to understand science, which reason usually not as good as the scientific method. Now, by the 1700s, all chemists agreed on the existence of atoms. Now, the atoms combined to make compounds, but they still didn't agree on whether elements combine in the same ratio when making a compound. The law of conservation of mass states that mass is neither created or destroyed during regular chemical or physical changes. And what we see here as an example, we see that we have 6 fluorine atoms, which make up 3 fluorine molecules. And since each fluorine has a mass of about 19, 6 times 19 gives us 114 grams. And then we have 4 hydrogens, which comprise 2 hydrogen molecules, with a relative mass of 1, which gives us 4 grams. So in the beginning chemical reaction, we're putting 114 grams plus 4 grams together, which is a total of 118 grams total. So we must see 118 grams in our product, because we can't create or destroy mass. So we see that we started with 6 fluorine. We have 1, 2, 3, 4, 5, 6 fluorine atoms. And we had 4 hydrogens. And we have 1, 2, 3, 4 hydrogens. So this is done correctly. Now, we see that we've changed into something different, but we still have the same mass. 118 and 118. Now, the law of definite proportion states that any amount of a compound contains the same element in the same proportions by mass. An example of this would be copper carbonate. We see that copper carbonate has 57.48% of it is made of copper, and 36.18% of it is made of oxygen. And we see that 0.91% of it is made of hydrogen, and 5.43% of it is made of carbon. Now, these percentages will stay the same no matter how much copper carbonate we have. Okay? So we could have 1 gram or 1 billion grams. It would still have the same percentage per mass. Now, the law of multiple proportion applies when 2 or more elements combine to make more than one type of compound. Okay? Now, what we see here is we have nitrogen and oxygen. They can create and they make nitrogen monoxide. Okay? But we also see that nitrogen and oxygen are combining again, but now we have 2 oxygens, and it creates nitrogen dioxide. So here we see that we have nitrogen and oxygen. They're combining to make 2 different compounds. Okay? The main thing here, the difference between the law of multiple proportions and the law of definite proportion, is that multiple proportion deals with elements. 2 different kinds of elements making different compounds. Now, the mass ratio of the second element simplified to the smallest whole number. So we always simplify when we can. And this is another example of the law of multiple proportions. We see we have nitrogen and oxygen. 2 nitrogens, 1 oxygen makes nitrous oxide, or dinitrogen monoxide. And here we have nitrogen and oxygen, nitric oxide, or nitrogen monoxide. And then we have, lastly, we have nitrogen dioxide. So 1 nitrogen, 2 oxygens. Now, Dalton's atomic theory. Dalton's atomic theory states that all mass is made of atoms, and that atoms of the same element have the same size, mass, and properties. He said that atoms cannot be subdivided, created, or destroyed, and that atoms of different elements combine in whole number ratios to make compounds. And lastly, in chemical reactions, atoms are combined, separated, and rearranged. Now, the majority of Dalton's atomic theory is correct, but some of it was wrong. One place where it was wrong is that atoms can be divided. They are divisible into the smaller parts, which are the subatomic particles. And atoms of the same element can have different masses. That's where we get isotopes. Now, most important parts of the atomic theory are that all matter is made of atoms, and atoms of different elements have different properties. Now, the structure of the atom. Atom is comprised of the nucleus and the electron cloud. The nucleus contains the protons and the neutrons, and the protons are positive and the neutrons don't have a charge, and they take up very little space, and we can see that in the very center of the picture. They don't take up very much space. Now, the electron cloud contains the electrons, which are negative, and it takes up most of the space, and we can see that in the picture as the yellow. Okay, so nucleus, very small. Electron cloud, very large. Now, the subatomic particles include protons, neutrons, and electrons, which we just stated. Now, the charge on the protons and electrons are equal but opposite. And to make an atom neutral, we need the same number of protons as neutrons, or protons as electrons. Okay? So if we want it neutral, we need to have the same number of positives as we do negatives. Another key important factor is the number of protons identifies the atom as a certain element. Now, we see that on the periodic table with the atomic number. It's the number of protons in an atom. And we cannot change the number of protons. Now, protons and neutrons are about the same size, but electrons are much smaller. And we see that we have a strong nuclear force is when particles in the nucleus get very close together. They have a very strong attraction to each other. Atomic radius is basically the size of the atom. We measure it from the nucleus to the outside of the electron cloud, and we express this in picometers. And it usually right around 40 to 270 picometers.